Hello and welcome to Maths Pure Chemistry course, section 1, lesson 2. Today's lesson is on elements, compounds and mixtures. So introduction here. So last lesson we just quickly talked about the kinetic theory of matter, which is where we assume all substances are made of small particles. So these particles are very small and can only be seen using a very powerful microscope called an electron microscope. So, but some simple laboratory experiments can confirm that these exist. So even if you don't have a microscope, you can still confirm that they exist. So most commonly, these particles are atoms and molecules. And these make up elements, compounds, and mixtures, and that's what we're going to be talking about today. And then further on in the lesson, we'll talk about separating mixtures, and then we'll talk about paper chromatography, which is part of that, separating mixtures. There's a picture right down here of paper chromatography. So let's move on. Elements and atoms. So all matter is made from elements. So elements are substances that cannot be broken down into anything simpler. So this is because they are made of one kind of the same small particle. And these small particles are called atoms. And you can see we've got a diagram of an atom here. In this lesson, we're not going to be talking about what part of an atom is called, blah, blah, blah. That'll be in a few lessons later. And we've got an example of an element, and that is sodium. And you can see sodium here. Sodium is a metal, so this could just be a sodium salt, not too sure. Let's move on. So differences between mixtures and compounds. So a mixture contains two or more substances. So no chemical reaction takes place. So for example, you could get seeds and you could mix them all together in a big bowl. That'd be a mixture. But you're not combining them with, I don't know, you're not like melting them together or something like that. But a compound is formed when atoms join together in a chemical reaction. So in the bottom right down here, you can see that we've got an example of an element. So we've got some atoms bonded together, but they are the same element. So these two are elements, and then we've got a mixture, which is where we've got different elements that are next to each other, but they're not chemically bonded. We've got a compound, which is where different atoms are chemically bonded together. So we have 5 main sort of different ways that we can separate mixtures. So remember, a mixture is a when you mix or you put substances together with no chemical reaction. So we've got 5 different ways that we need to talk about. We've got simple distillation, fractional distillation, filtration, crystallization, and paper chromatography. Right, so let's just have a look at this. So simple distillation. So this is our diagram for simple distillation. So what you do is you have a flask, which you can see here. You heat the liquid inside. So we've got seawater here. And what's going to happen is when it evaporates, it's going to go up here, and the gas will go through here. And we've got a condenser here, which is basically you've got water going in and out, cold water. And that will turn the gas into liquid, and then the liquid water will come down here into this, and it's pure water because the salt will be left behind it and the impurities from seawater. Okay, so that's basically how simple distillation works. It's quite easy to understand, and there's not really many problems with this. A few things maybe to mention is that the liquid that you get over here is called the distillate, D-I-S-T-I-L-L-A-T-E. That's an important word. Another way you can do this instead of having a condenser is you can just put this whole thing into a thing of cool, so like a beaker of cool water, and then you have a test tube on the end of the pipe thing here. So yeah, that's everything for simple distillation. Let's move on to fractional distillation. So this is more complicated. So this is one type of fractional distillation, and it's easier to just talk about this first. So this is separating crude oil, which is oil that you find under the sea, made from the remains of dead plants or animals. So you've got the crude oil, it's heated, but crude oil is made of different compounds. It's not just one thing. So what happens is the different compounds separate in this thing called the fractionating column, and each layer is a different temperature. So what happens is the compounds are separated by their boiling points. So that at the bottom, so the solid things, so like tar, or we call it bitumen. So that is at the bottom, and because that is solid and really large molecule, so it's got a high boiling point, so it needs a lot of energy to undo, and we go up, and it takes less and less energy. So the ones at the top are gases. You get some liquids in the middle. Okay, so that's how fractional distillation works. It's the same principle as distillation, but the whole point of it is to separate compounds by their boiling points. Okay. Okay, filtration. Filtration separates a solid from a liquid. So for example, coffee grounds could be separated from the coffee by filtering through filter paper. Filter paper is like a sieve. It has tiny holes that allow the coffee to pass through but leave the ground coffee behind. So pretty self-explanatory. You just put the liquid solution into the filter paper, the liquid goes through and the solid is left behind, and you collect the liquid, and it's called the filtrate. Okay, now let's talk about crystallization. This is a bit more complicated. So what happens is you have a solution of one solid and an insoluble impurity, and that's what you make the crystals out. So you're going to, first of all, you're going to filter it using the filtration method we just talked about. And then it goes into an evaporating dish, which is this circular thing down here. You put that on top of a tripod or something like that, and you gently heat it to evaporate about half of the volume of the solution, so it's more dense with solid. And then what you do is you transfer it to a dish, and it's a hot liquid at this point, and then you leave it to cool in a windowsill or something like that, and you get a crystals form after solution is saturated. Okay, so that's how this process works. You may want to look at a YouTube video of this actually happening, just so you can see how the actual process works. I would actually recommend watching a video on every single one of these processes. And then finally, we've got paper chromatography. So, paper chromatography. Chromatography can be used to separate a mixture of several solids that are soluble. So soluble means that they can dissolve in a solvent. This is often used to separate coloured substances such as inks or dyes. And an interesting fact is that in Greek, chroma means colour, and that's why it's called chromatography, because you separate dyes and inks. So to separate different colours of dyes in ink, you put a spot of ink near the bottom of some filter paper, and then you put the filter paper in some water in a beaker. As the solvent spreads, so the solvent will climb up the paper, it will carry the dye, and the dyes will go up different lengths depending on what colour they are, and this is because of their solubility. So the more soluble something is, the higher it will go, and they go up at different speeds as well. So you can calculate this thing called rentation factors. So the equation is rentation factor equals distance moved by a substance, so that could be the dye, from the baseline, divided by distance moved by the solvent, which is usually water, from the baseline. So for example, on our diagram on the right, the water moves 10 centimeters, and let's say the red dye moves, or is it pink? The pink dye moves 2 centimeters. The rentation factor would be 2 divided by 10, which is 1/5, or 0.2. And it has no units. It has no units. So the rentation factor the rentation factor values will always be less than 1, because the solvent will always travel further than the substance. That's something important to know. Right, let's continue. And that is the end of this lesson. If you have any questions about anything I said, or if I said anything wrong, please just let me know and I'll try to correct it as soon as possible. Hope this lesson was useful. Please like, share, subscribe, and tell everyone you know about my channel. Goodbye.